Hello, once again, welcome. If this is your first time in this particular course or this particular channel, this channel is for computer application course, and it is for degree students who are taking computer application. So if you want to know more about the chapters and the topics to be covered, you can just check the overview video and you'll be good. For today, we'll be focusing on the review of Introduction to Computer because that is the chapter 1 of this particular course. Okay, the review of Introduction to Computer. What is a computer? That's the very important question that we need to ask, because for us to understand where we are going to, it will be good to know what we are dealing with. And here we said a computer is an electronic device. When we say an electronic device, what do we mean? An electronic device is any device that actually uses electrical charges or electrons in order to function. Okay, so we say a computer is an electronic device which is capable of receiving data as input. Okay, and this data actually simply means raw facts. Okay, and when we say input, we are looking at the computer's ability to be able to receive this particular data. So it's like a human being that has input devices. You may have your mouth to take in food and whatever thing that goes to your body. You may have your eyes to take in visuals. You may have your ears to take in sound. You may have your skin to take in moist and things like that. So your input devices take in data. That is the same thing with a computer. So it is an electronic device which is capable of receiving data as input and processing it according to a set of required instructions that are stored in its database in order to produce an output called information. Here, the point we are making here is that this particular electronic device receives data, and how it does this processing of data is dependent on these instructions that are stored. Okay, the different instructions actually do different things. So I may have, I may want to probably prepare rice, and I have two different people who have been asked to prepare rice. At the end of the day, they are all going to prepare rice, but the taste of the rice will be different because the processes at which each person, each cook uses in order to prepare the rice will be different. So this data processing that the computer does is dependent on the type of instructions. So if the instruction to process the data in a particular way does not exist in that computer, then the computer is not going to carry out that instruction. So, and these instructions are stored in the database where we have to talk about the storage facility of the computer in order to produce an output called information. So information in this case is actually a processed data or a processed fact or a processed data that carries a meaningful idea. What are the components of a computer that we need to be looking at? Computer is made up of two things, basically hardware and software. Now, the hardware includes the physical parts of the computer, such as the central processing unit, the random access memory, the motherboard, the computer data storage, the graphic cards, the sound cards, and even the computer case. Okay, it also includes external devices such as the monitor, the mouse, keyboard, and speakers. In other words, the hardware are all those things you can see, you can feel, and you can touch. That is the computer. Okay, so anything that is called the hardware, those are the things. But you see, the hardware in themselves cannot operate by themselves. They are just like lifeless. they don't have any life in them. They cannot talk to each other. They cannot relate to each other because they are just hardware. And that is where you need the software. The software is like the life of the hardware because it's the software that helps the hardware devices to talk amongst themselves. It is the software that also helps the end user, the person using the computer, to be able to, how do I put it, to be able to relate with this particular computer. So consisting of instructions written by a programmer using a computer language to solve a problem or enhance communication between hardware devices to serve as an interface between the hardware and the end user. That is a software. So if you look at this component, we are saying that a set of what? Instructions. These instructions are just step by step what to do. And they are written by a programmer. Now, when we say the programmer writes these instructions in a computer language, what are these computer language? Computer language, usually we have what we call the machine language. The machine language is the combination of zeros and ones, all these binary digits that you see here is a combination of zeros and ones. And why the use of zeros and ones? Because the zeros and ones are just a two-state circuit. It's either a 0 or a 1, and that's a binary. So it's either an off or an on. And remember, earlier on we said the computer is an electronic device. Invariably, electrons or electricity passes through it, or charges passes through it. So the charges is either positive or negative. There's either current or there's no current. That is why it is a two-state circuit of a combination of zeros and ones. Okay, and so this programmer uses this computer language, either the machine language or another one called the assembly language. Okay, assembly language. The assembly language can also be called low level language. Okay, then you have the third language called the high level language. Now, when the computer programmer is programming these particular instructions, he is actually doing it to solve a problem. This is very key. Can you see? In order to solve a problem or enhance communication between hardware devices. When you are solving a problem, that means there is a need for it. All right. So we're going to see that this software is divided into different types. So we have different types of computer softwares, which we're going to look at. The first type of computer software is called the system software. Okay. The system software. Now, the example of the system software is what we call the operating system. The operating system is like the main software that, or the fundamental program that helps to communicate between hardware devices. When you have the hardware, the operating system is like these instructions that is installed that will help the hardware talk to each other. At the same time, it helps you, the operator, to be able to talk to the system. Okay, for instance, you have operating systems like Windows. Windows come with different varieties. We have the Windows 7, Windows 8, Windows 10, Windows 11, and so on and so forth. They are all different versions of Windows operating systems. In other words, if you have your hardware device, if you don't install this particular Windows operating system, you cannot install the other application softwares like your Microsoft Word, your PowerPoint, and things like that. Okay, now another set of operating systems is what they call the Linux-based operating systems, where you talk about the Unix, the Linux, and it has different distros like Fedora, like FreeBSD, like Ubuntu, like Kubuntu, Mandriva, and so on and so forth. They are Linux-based operating systems. Okay, you also have the Mac operating system. All these operating systems, including Android, the ones that you have on your phone, okay, the Android, they are all operating systems because they are written by the programmer, usually using an assembly language or a machine language or a combination. in order to enhance this communication between these devices. Okay, so then we have what we call the language processors. The language processor converts high-level programming languages into machine-readable instructions. Remember that we said the computer has different languages. Okay, it has different languages to include the machine language, the assembly language, or the low-level language, and the high-level language. Now, we're looking at the system software. Another type of the software is called the application software, which we are going to see very soon. Now, in the application software, the programmer uses high-level language in order to write instructions to the system. So the language processor here that we're talking about actually converts these high-level programming languages into machine-readable instructions. Okay, so we also have what we call the device drivers, okay, which controls specific hardware devices and enables them to function within the computer system. You know, when you have a flash drive and you connect into your system, the flash drive is a hardware and it requires certain kind of instructions in order to help function very well. So if your system has that instructions, your flash will work well. If it doesn't have that instruction, you will need to install it. The same thing goes to a printer, the same thing goes to a scanner, the same thing goes to any of these external peripheral devices. So you will have to look at it, and then they're all drivers. So that is the system software. The system software, we said, is written by a programmer using assembly language or high-level language. And sometimes it helps to enhance communication between hardware devices and also serve as an interface between the end user and the application system, or the end user and the hardware. Now, application software on the other side is designed to solve specific problems. Specific problems include maybe word processing problems, graphic processing problems, web browsing problems, you know, specialized softwares that are designed to solve specific things. So you see, while the system software generalizes and looks at solving or providing a platform where application softwares can sit and then enable hardware to talk to each other, the application software in this case actually is designed for specific softwares. So these application softwares, we have what we call the general purpose software, versatile programs used for various tasks. Before then, application softwares usually are used by programmer using a high-level language. Okay, we have so many high-level languages. All right, a very simple common one that you may visit very soon maybe is Python programming language. Another one could be JavaScript. Another one would be Visual Basic. Another one could be C or C++. And there are a numerous number of them. We're going to see them maybe in later class. So we have general purpose softwares, then we have customized softwares, which are tailored for specific needs within an organization. For instance, a banking system may have a particular application software that they use for banking services. You don't expect that particular application in banking services to be used in the airport for aircraft control management. You cannot use that for that. You cannot use the application for aircraft control management to go and use in agricultural-based production, where you are managing your agri facilities. You cannot use the one in agri and then you want to use it for general applications. So different applications are customized based on the need. Then you also have what they call the utility softwares. The utility softwares provide tools for system maintenance and security and optimizations. Okay, so most of the times people that build operating systems tend to send these utility softwares as a patch, or people that produce a particular hardware component. All right, a particular hardware component, they may need to produce that particular utility softwares to enhance communication. Then you have another application softwares in the area of multimedia softwares. This is used for editing images, audio, and video, and things like that. For those who are producing video or those who go to studio to produce music and album, you use application softwares for that. You have application software in case of graphic softwares that helps you to create and manipulate visual content. Like you want to create pictures, you want to create images, you want to create flyers and things like that. You have Corel Draw, you have a Canva, you have a Photoshop, and all these softwares that you could use as graphic softwares. Then you have web browsers that enable users to explore the internet. Okay, you have like Edge browser, Chrome browser, Firefox browser, Internet Explorer, and a number of them. You can look at those browsers. But one thing is for sure, these browsers help the user to be able to browse the internet and access the web. Then you have education softwares that support learning and instructional purposes. Okay, so educational softwares, you know, there's what they call the e-learning softwares like Moodle. It's an educational software. There's the one that they call U-Lesson for most primary school, secondary school students particularly. Okay, and then you have another one called the Canva. You can also use it. And so many applications for educational purposes. Okay, then you have communication softwares that facilitate messages exchange. Then you have application suites, you know, that collections of related software. Example is what we call the Microsoft suite, where it has the Microsoft Word, PowerPoint, Excel, and the rest. Okay, the Access and so on and so forth. Now, let's look at classification of computers. Computers can be classified into various categories based on their purpose, their size, their capabilities. Let's explore some of them. We have what we call the supercomputers. Supercomputers, they are extremely powerful machines designed particularly for complex scientific calculations, simulations, and data analytics. Supercomputers excel in tasks like weather forecasting, nuclear simulators, and genome sequencing. All right. You also have notable examples to include the IBM Blue Gene and other high performance computings. Those are supercomputers, and they are called super particularly because of their processing power, their ability to do extraordinary processing. Then another type is called the mainframe computers. These are basically large-scale computers used by organizations for critical applications. They handle massive data processing, transaction, and management and database operations, and usually found them in banks, airlines, government agencies, and things like that. So you see, the mainframe is known for its largeness, okay, because of its processing. Supercomputers is meant for its speed, all right? Then you have what we call the mini computers, all right, or mini computers, also known as minis. They fall between the mainframe and personal computers in terms of power and capacity, right? So they are popular in the 20th century and were often used in small to medium-sized businesses. Examples could include the DEC, the WAX, the Data General, the Eclipse, and things like that. So those are examples of mini computers. Then you have the microcomputers, which is mostly where most of us are used to, all right? Where you have the desktop computers, usually you place under or on top of a desk with optional display. You know, you have like a TV-like screen or so. Then you have laptops. They are also microcomputers, and they are called microcomputers because of the size of the processor and the nature of the system. So you have laptops, notebook computers, and they're all portable in one. So tablet computers, touchscreen devices, you have smartphones, you have smart books, you have palm tops computers, you know, you have handheld personal devices, you have video games consoles and handheld games console built for entertainment, and so on and so forth. All these are part of microcomputers. And the key word here is micro, because they have a very small processing chip, and their sizes are usually smaller. So those are the classes of the computers. How about the types of computers? We have what we call the analog computers. The analog computers use continuous physical phenomenon to represent information. And when we say analog computer, we are talking about how the data is processed and displayed. For instance, if you go to a hospital and then you see a cardiograph that reads the heartbeat, it gives you the particular result in form of like a graph. And then as the heart is beating, it gives you like that's like analog, okay? Digital is just when it gives binary. It gives you in form of zeros and ones and things like that. So that's digital computers. A hybrid computer combines the features of both an analog and a digital computer, right? So super computers, we have talked about them. Mainframe, we have talked about them. Microcomputers, we've talked about them. Personal desktop and laptop, as well as smartphones, we've talked about them. Okay. What are the benefits of computer? Computers have significantly transformed our society, impact various aspects of our life, and let's explore some of the key benefits. One of it is work and productivity. So computers are now ubiquitous across domains, fields, and industries. What do we mean by ubiquitous? We simply mean that it is everywhere. No matter the field that you are using, you are in, you need computers. Computers are becoming the bedrock for all operations in our professions. So whatever profession you're in, whatever area of interest that you are in, the computers are actually there. So they enhance productivity by automating your task, managing your data, and facilitating communication from office work to manufacturing. So computers play a very vital role in streamlining process and improving efficiency. Then we have communication. That's another very important benefit to the human society. People worldwide can actually connect, engage, and interact using instant messages, emails, blogs, online forums, and social media platforms. Right now that we are even having this particular conversation is a very key important benefit of communication in terms of computers. The widespread use of computers has also led to the creation of new industries, sectors, and professions. So millions of people now have job opportunities related to computer technology, software development, IT support, and more. Very important, very, very important benefit to us all is education and knowledge. Have you observed now that anything you want to learn, you can learn it on the YouTube channel? All you need to do is pick a YouTube channel, subscribe to it, and then any update that is sent in that channel, you get notified about it. So computers have decentralized education. Education used to be in maybe one four-corner room like this, where people will sit down and then will be told what to do and things like that. But now, so before, everybody sits inside here. But now, education, if this is you, education is everywhere around you. Okay, so it has broken that barrier. So they simplify learning processes for students, whether they are in urban centers or even remote regions. Across access to information, online courses, and educational resources has expanded significantly due to computers. Okay, how about entertainment? Wow, users watch movies, sports, events, news programs, shop online, socialize, download videos, and play games, all thanks to the computer. Okay, entertainment is, wow, another thing. You can watch your Netflix, you can watch your Nigerian movies, you can watch any kind of movies you want. You can watch music, you can download them and things like that. So in summary, computers are integral to our daily lives, influencing our work, communication, education, and even leisure. Their impact continues to grow, shaping the way we live and learn, and also interact with the world. This is where we will draw the curtain for the review or the chapter 1 or review of introduction to computer. If you like this particular lecture, you can subscribe for more lectures as they come. Click notification, like, and share. If you have any questions, go to the comment section, type in your question, and then we will find time to respond to your question. Thank you for attending today's class. Look forward to seeing you by next class. Thank you.